Hello students, for 7th standard this is physics, 4th chapter, that is light energy. Now in the previous chapter you will have already learned about energy. Now in that you will have learned about different forms of energy. Out of that, one of the chapter was light energy. So here we will be focusing more on light energy. Now this chapter will be divided into 3 videos. The first video will deal with more about light energy and reflection of light along with laws of reflection, and about diffused, that is regular and irregular reflection. Alright. So you all have already learned about light energy, that I told you in the previous chapter that light energy is the only energy which is visible to us. The rest, all the other energies can be just either heard or felt. Right? Now things around us are seen to us. Of course it is because of our eyes, and it is also because light is falling on those objects. Alright? If the surface is a highly polished surface, you find that light, after hitting that substance surface, it bounces back. There are certain substances on which when light falls, all the light is being absorbed, and there are certain substances through which light can completely pass through. Okay, so depending on whether the light is being absorbed, whether the light is passing through it, or whether the light is partially absorbed and partially reflected, we can in fact name these objects accordingly. Okay, so suppose you have a surface like this. You have a surface like this. When light falls on it, light ray cannot pass through it. For example, now I am flashing a torch beam here. I cannot see the beam on the back portion, so that means light is being absorbed. Okay, so such surfaces are called as opaque substances. Suppose light can pass through it completely. Like for example, window glasses, window panes and all, you find when you incident light on it, light can completely pass through it. Such substances are called transparent substances. Like glass, water, these are examples of transparent substances. There are certain substances or certain materials through which some light will get absorbed and some light will get reflected. Right? So such substances are called as translucent substances. For example, butter paper, frosted glass. These are examples of translucent substances. Now here you all will be learning about reflection, the term reflection, when light after being flashed on a particular surface, it is being reflected. Now what are the criteria for this light to get reflected? Now reflection means it is bouncing back of the light in the same medium. If I am using air as a medium, light will bounce back in the same medium. Now for this to happen, the surface has to be highly polished. Like for example, a mirror. I've got a mirror, and this mirror, you find when light falls on this, it gets reflected. Alright? Now what is reflection? Before I give the definition for reflection, I'll just show you. Now if I take this spherical object and hit it against the surface of this, you find after reflection, after hitting the object, it travels at a certain angle. Right? If I hit the object straight, it comes back, it bounces back in the same direction. But if I hit it at a particular angle, you find at another particular angle with respect to the point where it is hitting at a particular angle, same angle in fact, it bounces back. Okay, same thing is being observed in case of reflection of light, right? So same thing, when it goes straight, it comes straight. When it hits an object at an angle, it reflects back. Reflection can be shown using a highly polished surface. Now I've used a mirror. Now and a torch. When you flash a beam of light on a highly polished surface, now this is a mirror, you find that a ray of light, after hitting the surface, the ray gets reflected. That means it bounces back. If I place the torch in such a way that it is straight, a ray comes and hits the mirror and goes back in the same direction. So how do you define reflection of light? Now reflection of light is nothing but bouncing back of light when it hits an opaque object, and it bounces in such a way that the angle which is made is important. It bounces in such a way that that angle is same as the angle between what is called as the point of incidence and the ray that is getting reflected. Okay, so this is reflection. Now related to reflection, there are many terms. Okay, first term is the ray that is striking the mirror. That ray is called as, now in this case, this ray which comes from the torch and then hits the surface, this ray is called as the incident ray. Okay, it is called as the incident ray. Now this ray will hit the surface at one particular point. That point is called as the point of incidence. Correct? Now at the point of incidence, if you draw an angle in such a way that it is a right angle, or at an angle, it is 90 degree with respect to the surface. So that angle, that line is called as the normal. Now after reflection, the ray moves at the same angle with respect to the angle made by the incident ray and the normal. So that ray which emerges, which goes out and which gets reflected, that angle is called as angle of reflection, and that ray which is getting reflected is called as reflected ray. Okay? And this surface is called as the plane surface which is being used. Now after knowing these terms related to the light incident on a plane surface, there are two laws which you all need to know related to reflection. Now what are these laws? The first law, it states that when the ray is incident on the mirror, or for that matter any highly polished surface, the angle that is made with respect to the normal, now this is the incident ray, you have the normal here, this angle is equal to the angle made by the normal and the reflected ray. So we say that the angle of incidence is equal to angle of reflection. This is the first law under laws of reflection. And the second law is that the incident ray, the reflected ray and the normal at the point of incidence, they all lie, all these rays, incident ray, reflected ray and the normal, they all lie in the same plane. This is the second law of reflection. I'm going to repeat. First law is that the angle of incidence is equal to angle of reflection. Second law is that the incident ray, the normal and the reflected ray at the point of incidence, they all lie in the same plane, right? Now towards the end, I'm going to tell you all about diffuse, or we call it as regular and irregular reflection. Now what is this regular and irregular reflection? Suppose you have a surface which is a smooth surface. Now incident light on it. So all the rays which actually, now for simplicity purpose, we consider these rays to be just as one straight line. But in reality, even a torch beam, you find there will be many rays striking at the respective points of incidence, and they get reflected. So if the surface is a regular surface, then you find they obey the laws of reflection. But if the surface is irregular surface, now what do you mean by irregular surface? If there are, for any surface, if there are many ups and downs, like for example, this surface is not a regular one, so there will be many ups and downs. If you look at it with the help of a microscope, you'll be able to see many ups and downs. So in that case, when a torch beam is incident on this, all the rays will not emerge parallel to each other. So such reflection is called as irregular reflection or diffuse reflection. Now why is it so? Because the surface is not smooth. Whereas when you're using a mirror, the surface is smooth surface. So all the rays after reflection, they go parallel to the reflected rays, they go parallel to each other, which is not so in this case because the surface is rough surface. Correct? So far in this lesson, you will have learned about light energy, you will have learned about reflection, different terms related to reflection, and laws of reflection, the two laws of reflection, and towards the end you will have learned about regular and irregular reflection. In the next video, you all will be learning more about reflection. Thank you.